Okay, today's going to be interesting. Couple of notes. I'm just trying a new mic setup, and hopefully it's better. But I don't know how the audio quality is going to turn out, so we'll find out. I found out with a new microphone, you can hear everything, including my CPU fan. So that's pretty annoying. But I'm going to order a Noctua heatsink, which is better than this Intel stock cooler, I think, by quite a margin. So the next video will be better. But anyway, so today I want to look at graceful restarting, and it's kind of a tricky topic because, well, first you got to define what it means to restart gracefully, and then you have to consider the scenarios which might make it impossible to restart gracefully. So let's have a look at this example. It's in async.io. You can try this out yourself, but actually I think it may not work on the current release of async. I've got a build that I'm working on locally, which changes some of the behavior of how task.stop works. So we'll have a look at this because it's kind of interesting to see. So this is the client implementation. It's really pretty straightforward. We make an async block and we connect to localhost port 4578. We go around in a loop, we sleep for 1 second, and then we send the message, hello world. We wait for a response to come back when you print it out, and we just do that forever. And I guess this is kind of simulating a client which is communicating indefinitely, and our goal is to basically be able to gracefully restart the server. I don't care about the client so much, it's more about the server implementation. So in order to implement this in Falcon, I wanted a really simple proof of concept so that I could look at the different trade-offs and the different design characteristics that I'd have to consider. So this is a server implementation, and we're going to trap SIGINT, the interrupt signal, when you press Control-C on your keyboard. So we make this interrupt trap up here. This installs it, so it's sort of the same as doing signal.trap, but it's not quite the same because this has to work. It works with async container, which can be either multi-process or multi-thread, and this will work in both environments without you having to consider whether it's in a forked child process or in a separate thread. So it uses notification pipes, and that's okay because the overhead of this operation is pretty high in the first place, so the fact that it's using an IO for receiving the notification isn't too bad. So the server, we bind to localhost port 4578, and because my computer has IPv6, that's going to be there'll be two bindings. Then we basically make an async subtask, and we call interrupt.wait, and this will just wait indefinitely until the user presses Control-C. When that happens, we call server.close. Server is the socket that the server is accepting connections on. So this immediately stops the server from accepting any new connections. Then we change the interrupt back to the default behavior. That means if the user hits Control-C again, it will kill the server completely. And the logic of that is that it's pretty annoying when you press Control-C and the server's like, yeah, I'm shutting down. And then you press Control-C and the server's like, yeah, I'm shutting down. And you press Control-C and the server's like, yeah, I'm shutting down. Basically, if something goes horribly wrong in the graceful shutdown process, the next time you press Control-C should basically just kill it, in my opinion. So I have put in a timeout of 4 seconds just because we wait for 4 seconds after this for connections to drain, and then after 4 seconds we forcefully kill the server task, which also kills any child tasks, which are the connections that are currently running. So I guess maybe the next step is to have a look at how it works. So I'm going to change this to, like, let's just try 10. And we will run the server. So the server's bound to IPv4 and IPv6. And we can happily connect a client to the server, and we can connect more than one client. And they are all communicating, doing their thing. When we come into the server, so let's kill this one. So I'm going to press Control-C in the server process. So it's now closed the server socket, so I cannot connect, but my other processes are still continuing to run. In theory, if it was an HTTP request and response, like, hopefully it's not running indefinitely, but in this case, after 10 seconds, it basically forcefully shut down the connections. And what I've done is I've printed out the hierarchy of the server. So you can actually see, actually I'm printing out the reactor hierarchy, so it's a little bit confusing. I probably should just print out the task hierarchy. So that is IPv6, and you can see there's the 2 connections, the 2 tasks running there. And I don't know which one it killed first. It looked like it might have killed IPv4. Was it? I can't actually tell from this backtrace. But anyway, yeah, so basically you killed both of those tasks. Now, I'm pretty happy with how this is fitting together, but I guess the next step is to see if we can retrofit this into Falcon. So Falcon, as has been discussed previously, there is sort of a command called serve, and that command is primarily for development. So Graceful restart doesn't make a huge amount of sense. I suspect people are trying to use this command in development to replace Puma. So we can try it as a prototype and see if we can make it work. It's at least a little bit interesting to try it out. There are some complexities that will come into it, but we'll see if we can make it work. So this is I did not want to do that. This is where Falcon spins up server instances. So the run method parses the options that the user provided, and then it binds and creates a shared endpoint. It does this because if you fork a process, in Linux you can do reuse address, but it's not that well supported across different platforms. So using a bound endpoint before you fork is the easiest way of sharing a single server socket. Right, so there's a debug trap. This is user 1, and the reason for that is that when you do that, Falcon will print out the hierarchy of all connections, which is kind of useful if you are trying to debug what is going on. So let's try that and see if we can. So the bear example is probably a really good one to try out. But let's just run it with one process. Otherwise, we're going to end up. So what port is it? 9293. Oh, was it running on HTTPS? Should have been. Ah, 1992. My bad. Okay, so that's doing its thing there. And if we so we did that, and it told us that we have a task that's running. We have a task which is waiting for user 1, which is the one we just triggered. We have a server task. It's accepting secure connections to that address. And then we have this task, which is the connection. It's got a background reader for the HTTP2 protocol, which is running. And it's got an incoming request, which is get slash, and then that's finished, but there's actually a nested task which looks like the bottles of beer task. So it was up at bottle of beer 68. It's been annotated. And then there's another task which is writing the output of that, writing body deflate to async HTTP protocol HTTP2 request stream ID 1 state half close running. So it kind of tells you what's going on in that connection. And we don't want to interrupt that. We don't want to change behavior because it's kind of useful. Right, so we need to make a new trap. Maybe we should just call it what it is. Why did I do ignore? Probably because it's just ignore in the parent process. For Graceful restart, it's a little bit different. We just don't want to kill the parent process. We want actually, because container.wait down here, it's slightly more tricky. The container will already restart processes when they're killed. So it could be that we just get the processes to self-destruct when they're interrupted, and then the parent process will restart them, which is probably acceptable. So let's try this. We're going to wait for that. Now, this is actually even more tricky because there is no way to tell the server to stop accepting connections yet. So we might have to change that implementation. Oh, we have a bound endpoint, so maybe we can just close that. It might work. We can try it. So that's the shared endpoint, but in theory, we're in a child process. It's a little more complicated because in the container, when it's multi-threaded, this will only be executed once, whereas in the child process, it will be executed once per child process. I think that's correct. And the reason for that is because there are some things you can't easily multiplex and transparently handle between multiple threads and multiple processes. This may be more tricky than I imagined, but let's see. Maybe there needs to be a way in here, rather than calling lockdown endpoint.close. I just need to tell the container that it needs to shut down. But let's try it. It will definitely work in forked mode, but it probably doesn't work in threaded mode. Okay, right, so and the other thing is, if there are no connections, there's no point waiting. We could just restart right away. So this is kind of a little bit silly. Maybe that works. Let's try it. Yeah, and I guess the other thing is it's kind of annoying on the development server. When you press Control-C, you just expect it to shut down, not restart. But that's okay. We'll see if we can make this work. And then we'll figure out what the UX should be like later. See how we hit it. Yeah, roughly. Okay, does anything work? Hold on, we need to use the local copy. What have I done wrong there? I think I didn't install async. I did not realize I was that far behind. Okay, cool. Okay, I think this might kill the parent process, but that's what it's all about. Exciting live programming. I didn't print anything out. Okay, and it died. That was graceful. Okay, right, let's add some logging. Oh man. I can only live stream when everyone else has gone to bed because it's too noisy otherwise. Okay. We don't need a block here. So I guess the problem with this is before we stop accepting connections, we should actually spin up a new instance, because this is the whole point, right? If you're doing a rolling restart, you should spin up new instances before the old instances stop accepting connections, or something like that, I guess. So let's just get that there. So we're going to tell the child process to shut down. Okay. Okay, it did work. It's not a rolling restart, but it is gracefully restarting. But this connection took longer than 10 seconds, so it was terminated, which is actually okay. And I guess we should probably consider that like an error. And I guess some of the tricky situations where this can occur is if you have long-running WebSockets. How do you handle that? Obviously, you need to terminate the WebSocket. Excuse me. So let's see. I think the changes to the container code are probably too much for this stream tonight. But I am pretty happy that we could just get this basic thing working. Maybe it's interesting to think about what is the logic that should happen, because I guess there's a question of whether the container itself is responsible for this behavior or not. The tricky point is that with a rolling restart, if you have a web server like Falcon running, it has loaded your application, and if you are using a multi-threaded configuration, you cannot just restart the threads and load a new application to those threads. If you have changed the bundle, like if you've got different gems with different versions and stuff like that, you can't just load those updated gems into your current process. You actually have to restart the whole process. So that is something which is interesting, because in that situation, so this container is either starting up, in my case, one thread or one child process. And so it's actually the parent process which needs to restart itself to be to do a graceful restart. So what needs to happen is the container needs to, in the case of threads, like, it's actually impossible because it's the process itself that has to restart, and that needs a parent process to coordinate that, I guess. So it may be the case that putting this in Falcon servers is the wrong place, but in Falcon Virtual, we actually create a container which has other containers inside it, and those containers, those are the things we want to target for restarting. So the way Falcon Virtual works is we load multiple applications into this, and those applications are spawned into the container. And let's have a look at that spawn implementation. That calls bundle exec path after like dropping privileges and a bunch of other stuff. And that path, that is actually the path to, like in the case of this one, this falcon.rb file. And that is actually running something called falcon-host. And that itself spins up a container. So it actually creates a container somewhere in here. It should be. Oh yeah, here. Okay, right. So it's spinning up a container and then waiting. So we actually have nested containers. So for the purpose of the graceful restart, what we actually want is for the user to be able to say, this application, please restart it gracefully. And so it does a rolling. So it should spin up and copy of that, like a new version of that container, and then the old one should be shut down. And actually, it shouldn't be too tricky to do that because we actually have a proxy which is managing all the requests that come in and sending them off to those child containers. So let's have a go and see if we can actually get that working. We've got a bit more time left. What's the time? Yeah, we've got a bit more time. Okay, so that is interesting. What the hell is going on there? Okay, great. So let's see if that is working. Okay, great. So how do we want this to work? I am going to pull this code out because I don't think it's particularly useful here. You can also already do ungraceful restarts with Falcon serve. You just kill all the child processes and they'll be restarted. So the tricky thing is that containers aren't running inside they don't run inside the reactor because they use processes. They're slightly more complex. So I may end up unable to show this or demonstrate it, but let's see if we can get something working. It might end up having to go into the container itself, the container library. Or maybe it's the supervisor's job. So the supervisor is a process that runs alongside the child container. So if we put that in there, and is it going to bomb out again? Oh, it's going to be okay. And then so we have this supervisor IPC. And that talks to this process. There's actually another process running, some PID 11889, and it can do stuff like, it looks like I've got a half implemented restart command. Sorry, excuse me. So the reason why this exists and is useful is because the supervisor runs at the same privilege as all the other processes, so it can conveniently manipulate them. But it may require, we might have to get a list of all the other processes. It didn't have access to them. Like, I mean, it has access, didn't have like a list of them. It will restart. I'm not even looking at the right code. Okay, so restart is already implemented, but it's not graceful. Let's try it and see what happens. Okay, so it kills everything. That's not very graceful. But that is interesting. So if we implement a graceful restarting in here, that would actually be sufficient. Okay, let's have a look at the container library and see how that fits together. You'd think I'd know all this stuff off the top of my head since I wrote all of it, but I guess at a certain point you just write so much code that and when you write it in the first instance, you don't always consider that you want to do some particular functionality in the future. So there's two bits to this. There is a forked container and a threaded container. So this function here, it's actually pretty funny. It uses fibers. It just doesn't use async. It makes a fiber, and then it uses another gem that I made called process group. And process group is, it helps to manage a group of processes, and it uses fibers to do that. So each process that you spawn uses a fiber to monitor its exit status. And you can do stuff like this. So we make a new fiber, we fork, and so that's running in the child process, that code there. And then we wait for the exit status to come. If it was success, then we're finished. Otherwise, we log the failure. And if we should restart, then we log that we're going to restart, and we just basically come to the tops loop and do the whole thing over again. And so there's 8 fibers running in the parent process, which are managing those 8 children in the specific case of this instance over here that's running. So the interesting thing is, like, if we need to implement logic for Graceful restart, it could fit in here somehow. The interesting thing is we probably it gets more tricky because we need to tell the child process, which is running the server instance, to shut down its sockets so it stops accepting new connections. And we also, in a way, we want to spin up another process to replace it before we do that. It's tricky and it's super late at night. Oh man. Okay, let's think about this. There's this base class. This is when you call run, it gets the number of processes in your system, and it does spins up a number of processes. And this method async, it means it makes an async reactor to run the user code. That can either be per thread or per process. I guess it's logical that we propagate interrupt to the children and they can close the server socket. The question is, the restarting behavior. We almost don't want this restart loop because we're going to spin up completely new processes. But only when we want to gracefully restart. It's at moments like these I wish I have some kind of divine inspiration about how the code should all fit together. We're not getting it yet. We definitely need the ability to trigger the hosts to stop accepting new connections, but I guess the way I'm thinking about it is I want to do it in a way that's generic. So I don't want to, I feel like this should just work in a way which doesn't necessarily tie the implementation to signals or doesn't necessarily involve when I like to build systems, I like to think of them as a nice, delicious layer cake. And I don't like it when one layer reaches through another layer to interface with functionality and something which is one layer like that's further away. So I'm just trying to think, how do these layers, like, so Falcon is running inside async container, and async container obviously has its knowledge about the processes or threads that it's managing. And to me, it makes sense that async container is probably where this functionality lies, especially because it's going to be different depending on whether it's threaded or forked. But there's a certain piece of the functionality which is beyond what async container knows about, which is the server sockets need to be shut down. So somehow, even if we have like a function, just, hypothetically speaking, this needs to somehow tell the async code that some event has occurred, i.e. in this case shutdown. Async container knows about the reactors. It explicitly creates them, but it doesn't actually keep track of what they're doing. In the past, I did actually have like an array of like it is possible. You could have like a list of them, and you could, in theory, inject events into that somehow. But signals should be enough. Like, signals should make the most sense. But there's definitely a difference between shutdown right now versus a graceful kind of like, please stop accepting connections and terminate any connections after 20 seconds. Oh, in the meantime, please spin up a new connection, like spin up a new instance. But it should be pretty straightforward spinning up a new instance. But then in the case of the old one, we need to like manage that. So this loop has to terminate. Okay. Oh, and I guess the other tricky thing is I can't break existing systems, even though I think this is still on 0.x. So I guess I could break stuff, but I want to avoid doing that. It's already handling SIGINT here. Let's have a look at the process group code. So this is another gem called process group, and it just manages process groups, surprisingly enough. It's a very descriptive name. A process group in Unix is it's literally the first process you make that you fork or spawn can become a process group leader. And if it does that, then when you send a signal to the negative process ID, so that process's process ID, just take the negative of that, and if you send a signal to that, it will send it to all the processes in that group. So it's quite a useful way of managing multiple processes if you want to kill like a whole bunch of stuff, rather than trying to like ask the operating system, give me like a list of processes I should send interrupts to. You can just go send an interrupt to every process in this group. But this code is handling interrupts, and it just does it because it's blocking. And it does it in a way so that there's, in theory, no way that it can't clean up, which is quite a good thing. I'm feeling less and less inspired. I might just call it a night. But that's how all those bits fit together. We have looked at all of them, and it's just a matter of where those puzzle pieces fit. I did not want to open that. I might spend a little, I guess I'll spend a little bit more time looking at it. But yeah, I feel like I'm not really getting the inspiration I need to solve this problem. Problem solved. If I could just fill in the blanks. So how the supervisor restart works is it sends SIGINT to the process group, and the supervisor is part of that process group, so it ends up killing itself, but that's okay, it gets restarted. What we almost want to do here is somehow So I guess that's one option. Tell the parent of this process group to spin up a new process. Spin up a new process group container. The only problem with this approach is, I guess, that not in not every situation do you want to restart all the processes in the Falcon host environment. Like, the supervisor doesn't need to be restarted, strictly speaking. It's okay that it does, but but yeah, I think this is the logic that we need to implement. Tell a parent of this process group to spin up a new process group or container. Wait for that to start accepting new connections. Stop accepting connections. Wait for existing connections to drain. Terminate this process group. I don't quite know how to do that bit. That is essentially the command I want to start up a second time. So what I want is if we're asked to restart a given container, the problem is containers don't currently track. I have to make containers track, some way of tracking, so I can actually select a specific instance to restart. I don't think they support that at the moment. What does container.spawn return? Yeah, it doesn't return anything I can use to hold on to that specific thing. Yeah, I think I have to, it's going to be something to do with async container. I have to like make that support when you make a child reactor, be it a thread or a process, there needs to be some way to manipulate that in excess of what I've currently got available. Okay, well, we didn't make a huge amount of progress on this whole thing yet, but as you can see, it's a pretty interesting area. And while we support restarting, it's not graceful. So I hope the next step will be writing some specs in async container, but I think going to bed sounds pretty good right about now, so I think I'm gonna like give up, and it's okay. I'll sleep on it and hopefully I'll get the inspiration I need. Excellent. Oh, thanks for watching, and I hope that was informative.